Hey guys. So obviously we missed class today. So I wanted to just go through the lesson and just have it available in case you guys need it. So our lesson today is on dilations. Okay. So apparently that's my pet bird right now. My apologies. All right, so the thinking question is just a translation. For this one, it would be translating it up from M, 1, 2, 3, 4, 5 units. And if you look at L, 1, 2, 3, 4, 5, U, 1, 2, 3, 4, 5. So the translation is 5 units. That's really hard to see. Switch that, 5 units up. So remember, translation just shifts it up, down, diagonal. It doesn't rotate it. It doesn't reflect it. It's just literally moving a piece of paper along an axis. All right, so today we are going to explain the concepts of a dilation, and this is the only transformation that changes the size of the image. So we're going to be looking at dilations, and we're going to identify the figures that demonstrate this transformation. So our first slide here, and I'm not going to lie, totally took this from Google. It's from mathbitsnotebook.com. I had a really good explanation, and I really did enjoy, oops, I forgot to clear my slides. Sorry. There, my drawings, there we go. Now it's not all polka dotty. It just had a really good explanation and application of it as well. So dilation is a transformation that produces an image that is the same shape as the original, but is a different size. So this right here would be the, oops, again, wrong. I'll get this right today, guys. Switching platforms. Here's the original, and then when they dilated it, it got bigger, okay? So a dilation can be an enlargement, which is what this is right here. It's an enlargement. It's getting larger than the original image. And then it can also be a reduction. So you can make things smaller. There's some good examples on the next slide of the application of this. But just know that dilations can get larger and they can be smaller. A description of dilation includes the scale factor, how much bigger it's getting, or how much smaller it's getting. So the scale factor is just telling you how big or how small it is getting. It also does have a center of dilation, just like the center of rotation. Center of dilation tells us in which, I don't want to say in which direction it's being dilated, but there's always a point where it keeps the same size. So as long as it's all about this point, it's going to keep the same size. So it has that center of dilation as that fixed point in the plane. A scale factor greater than 1 is an enlargement that expands. A scale factor between 0 and 1 is a reduction, it contrasts. And if the scale factor is 1, the figure and the image are the exact same size. They're congruent. Okay? So honestly, in that case, if the scale factor is 1, it's not really a dilation because it's not getting any bigger or any smaller. All right. The word dilate is often heard in relation to the human eye. I don't know if you guys have ever had your pupils dilated, but whew, you are blind for a little bit if you do. But this is just a demonstration of what dilation means. And on that note, let's go ahead and take a look at our real world dilations. I love these. These were so good. Anytime you order pictures and you get a smaller size or a larger size, it's a dilation. Okay, you can get really big pictures and you can also get the really small pictures. The little Russian dolls that go inside of each other, obviously those are dilations. They're just getting bigger if you go this way, smaller if you go this way. The zoom feature, hello, like that's like the definition of a dilation. If you zoom in on something or you zoom out on something, that's a dilation. The drink sizes at your local fast food places, those are dilations. Product logos can come in a variety of sizes. So you guys can't see my t-shirt, but I have a K-12 design on my shirt, and obviously this design is not going to be the same size on my shirt as it is on a little kid's shirt. It's going to be smaller. So understanding dilations in that aspect, there's a lot of relational real world relations with this. All right, let's keep going. This dilation is an image. It has a scale factor of 2. We talked about rules in the last couple of problems, and I wanted you guys to see that dilations have the rules as well. They took this original orange triangle right here, and they made it bigger. They expanded it out. So what they did is they used this rule down here, and they just applied it to each point. So 0, 2, right? 0, 2, it's this point right here. If we take it and plug it in here, we would get 2 times 0 and 2 times 2, which gives us 0, 4. So our new coordinate is now up here at 0, 4. And then they would do the same thing with B. 2, 1 becomes 4, negative 2. Sorry, 2, negative 1. My apologies. 2, negative 1 right here. When we multiply both of those values by 2, it becomes 4, negative 2. And then C is negative 2, negative 2. When we multiply both those by 2, we get negative 4, negative 4. So we're just taking that image and we're expanding it. I keep using my hands, but I don't think you guys can see me, so I'll put myself over here. Bye. So little triangle gets bigger, and you can apply your rules. All right, let's go ahead and go to our next one. Our next one is a dilation, but instead of getting bigger, it's getting smaller. Okay, the new image. Okay, these are actually called pre-image and image. The image is the new one. The pre-image is the old one, the original. So if we're looking at this, the A, B, C, D, without the little primes, the little apostrophes, the blue one, the blue parallelogram is our original figure. And then we're shrinking it to get A prime, B prime, C prime, D prime. That smaller yellow parallelogram is what it is. Okay, so just like the other one, all we're doing is we're taking our original coordinates. Instead of multiplying by 2, we're multiplying by 1/2. And here's a cool thing to remember. If you're multiplying by 1/2, it's the same as dividing by 2. So if we just divide all of these by 2, negative 2 divided by 2, negative 1. 4 divided by 2 is 2. So this coordinate, negative 2, 4, negative 2, 4, is now going to be negative 1, 2. So when you are looking for the new points or the coordinates of the image from the pre-image, just apply your rule. Whatever that rule is, just apply it. If you aren't giving your given the coordinates or given the rule, they may just say, hey, it has a scale factor of 1/2. Then you can just literally take the sides and cut them in half. Okay, and we'll look at a problem like this here on the next slide. Okay. All right. So this one actually is a dilate the image by the scale factor of 1/2. We can use the same rule that we just did on that last one. Figure out our current coordinates, multiply them all by 1/2, and they get our new coordinates. So like this would be 0, 0. So if we divide by 1/2 on both of those, which is multiplying by 1/2, 1/2 times 0, 1/2 times 0, you're just going to get 0, 0. So that piece won't change, okay? It's still going to be 0, 0 right there. All right, let me switch colors. Let's do pink. The next coordinate is at 2, 0. So 1/2 times 2, comma 1/2 times 0 is going to give us 1/2 times 2 is 1. And 1/2 times 0 is 0. So 1, 0. And I'm doing the rule just in case it's not always easy. Like this one actually is kind of easy, but that's okay. All right, so this coordinate right here is 2, negative 4. We're going to apply the rule, 1/2 times 2, comma 1/2 times negative 4. And that's going to give us 1, -2, which is right here. And obviously, we really I don't feel like we need to do that last coordinate. If you want to, you can. You're going to see it's going to be 0, -2. So our rectangle is here. Now, I went through that rule process like I told you I would, but I also want you to see, like they just took this length right here, which was 2, and they just cut it in half, and we went to 1. And then we had this length in 4, and we cut it in half, and it went to 2. So you don't have to apply the rule in a situation like this because you can visualize what's happening. You're just shrinking it by 1/2. Or if you are more comfortable with the rule, use the rule. Personally, I like the rule, but that's just me. All right, we are going to clear my page. Oops. Didn't realize I switched to the pen on the, just whatever. Let's go ahead and solve that. And we'll look at this one. All right, this one. Now, we're going to pause it right quick, try the rule, and see if you get it. I'm just going to take the fact that I know that everything is going to be 3 times as large. So 0, 0, again, it's just going to stay at 0, 0. If I'm going out to 4, 3 times 4 is 12. So that's going to come all the way out here. And then this is 2 units, right? So I'm going to expand that to 6 units. So that's going to be way up here. And then all I have to do is connect them. Again, if you want to test that rule and just multiply all the current coordinates by 3, you're going to end up with these coordinates. All right, on that note, our last slide is our exit ticket. Pause it, and I do want you to try it. You don't have to email me the answer. I'm actually going to go over it, but I do want you to pause it because this is like one that's on your quiz. So this one has a scale factor of 8/3. So if we look at, let's just start with this one. Here, let me switch colors since that matches so well. Okay, that coordinate is 0, 3. And remember, if it has a scale factor, all we're doing is we're multiplying each x value and y value by that scale factor. Okay, the first one is just going to be 0. 0 times anything is 0. So 0 times 8/3 is 0. 3 times 8/3 is actually 8. Okay, so this new coordinate would be right here. Okay, and you can do this for all of them. Okay, 3, this is 3, 0. 3 times 8/3, that's going to give us 8. -3 times 8/3 is going to give us -8. And guess what? -3 times 8/3 is going to give us -8 again. So you can go through all your coordinates, but since in this situation they're all pretty much the same, all you have to do is apply that knowledge, and then you just made it 8/3 bigger. All right, I hope this helps. If you have any trouble with dilations, please do not hesitate to reach out. We can definitely work on it on Friday as well. All right, guys, I hope you have an excellent day.